Hey everyone, welcome to your Play Posit for the week. Today we are going to be covering 2.11. So go ahead and grab your notes and we will get started. We're finally to the whole enchilada, if you will. We are going to be factoring trinomials, which is one of, I don't know, it might be like one of the most foundational skills in algebra that you will take to every single math class that you take from here. So it's one of those skills that we're going to work on together and we're going to get through as a team. We're all in. We can do this. I know we talked about this in class last week, and just know that I am with you every step of the way. We're going to practice totally fine. So here's the first one. It's a trinomial, right? There are three terms. 1, 2, 3. We have a B here. That's okay. You know, we could have any letter. And this is when I mentioned that there are I know at least 4 different ways to factor trinomials. And you may or may not learn all 4, but if you do, you can pick your favorite. I have a favorite because the method that I choose to use and teach always works if it's factorable. You may have already done this lesson in the OMHS, and you may have seen a method called guess and check. And a lot of students like that method. It's kind of quick, but it doesn't always work, or it's not always straightforward. There's another method called slide and divide, and that one's kind of like a trick method. There is another one. Oh gosh, what's the other one called? Oh yeah, it's called the berry method. And I don't teach any of these 3 methods. I teach what's called, it's called the Ma chart. A Ma chart. And along with the Ma chart is factoring by group, which we did in live class. All right, so let's do it. We're going to multiply the first and the last terms. And this kind of is interesting because it's the reason we do this is relates back to FOIL. Remember, our goal is to get this to look like this, right? So we're going to multiply the first term times the last term. When you do that, that goes in the M because for multiply, right? So that's 7b squared. Okay. And our goal is step 2, to find a number that multiplies M to give you this, but adds to give you the middle term. So I put the number under M that we're looking for that's going to multiply to give us this, and I put the middle term under A because we're looking for it to add. That's why it's an A. So look, all we're going to do is we're going to start listing the factors of 7b squared. Okay, so that's 1b times 7b and 7b times 1b. Oh, negative 1b times negative 7b and negative 7b times negative 1b. These are all the pairs of numbers that would give us a positive 7b squared. And the reason I wrote these in different orders is because order can matter, especially when you're dealing with negatives. So what our goal is we want to pick the pair that adds to positive 8b. So it's this pair. We found it, right? Because 1b plus 7b is 8b. Okay, once you find it, step 3 says to replace the middle term. So instead of writing 8b, we're going to write 1b plus 7b. And here, we talked about this a little bit in class. Here's where order can matter because look, now we have 4 terms. Remember, when you have 4 terms, you can factor by grouping, which is our beautiful, easy method we learned in last class. So let's group the first 2 and group the second 2. And then we're going to look, and we're going to treat this as 2 tiny factoring problems and factor out the GCF of each pair. So for the first one, our GCF is B. So let's see what's left. We have a b left plus 1. Okay. Our next GCF, it looks like is 7. So we'll factor out a 7 from each of these, and you get b plus 1. Dun, 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 dun. It totally works because those match. Remember, we take the numbers in front, and then we multiply by one of those factors. The reason this works is because remember, b plus 1 is basically the GCF of these two terms. So we're factoring out the GCF. This is what's left. Now, kind of going back to this step up here where we rewrote the middle term, you can write it as 7b plus 1b and see if it'll work. Sometimes it works either way. Sometimes it only works one way. So if you can't find a GCF of the terms, you could always switch these and rewrite it. Because remember, addition is commutative, so it doesn't matter which way we put those terms, as long as it works when we factor. And it did. So what we can do now, and I wish I could get another color. I always say that. Let's see if, yeah, I don't know why. I won't try to mess it up. We can always multiply this out and we will get the original trinomial. So let's try FOIL. Remember? Or you could do the box method that one of our students showed us. You could do distribution. But it's kind of cool to see FOIL because that's where we get this whole process of the first times the last and the whole middle term. So b times b is b squared. Outside, b times 1 is b. Inside, 7b. And last, 7. See, look, there's that 1b plus 7b right here. That's kind of the reason this whole process works. And we get b squared plus 8b plus 7. And you can do your happy dance. So remember I told you last class, like, we know how to factor trinomials. It's just one tiny extra step before we factor by grouping. And that one extra step is doing the ma chart, finding those two numbers that multiplies together to give you the first times the last and adds to give you the middle term. So let's try it again. So we're going to create, you don't have to do this. I just make a little ma chart because it helps me remember. So we're going to multiply m the first times the last, and you get negative 12n squared. And then we are going to find numbers that multiplies to give us this, what adds to give us the middle term. So I'm going to write the 4n here because that we're going to look for numbers that add under a. So negative 12n squared. We have, and you might already know the numbers. Let's see. You could just list them all systematically if you want, but we're looking for a negative, which means one of them has to be negative, right? Negative 1 times 12, negative 2n times 6n, negative 3n times 4n. What else? Negative 8n times, no, not negative 8. Is that it? Okay. So now remember, with any of these, you can switch them. Like we could also say that it's a positive n and a negative 12n, a positive 2n and a negative 6n, a positive 3n and a negative 4n. And that's important when it comes to finding the ones that add. So we're looking for two numbers that add to give us a positive 4n. So, not that one. Ooh, this looks promising. Negative 2 plus 6. That's 4n. Yay, we found it. But look, this is 1. That's not it. This is negative 11. That's not it. This is negative 4. That's not it. So we found it. We found the two numbers that multiply to give us the first times the last and add to give us the middle term. So now we're going to replace the middle term with the two numbers we found. Because, look, negative 2n plus 6n is the same thing as 4n. It's the same thing. It's like a synonym. So we're not changing the value of the trinomial. We're just changing the way we're representing it. Okay, now this looks familiar and comfy. We know this. We're going to group the first two and group the second two. So the GCF of the first two is n. So we'll divide that out and see what's left. We have an n minus 2. The GCF of the second two is 6. And we have an n minus 2. It matches. So our final answer is n plus 6 times n minus 2. And we're done. We've factored it. Now, again, remember this step here where we rewrote the middle term. We could have written 6n here and 2n there and see if it worked. It doesn't, I want to say it doesn't really matter, but it might. Let's try it. Let's see. What if we wrote plus 6n minus 2n and factored this way? So the GCF here is n, and we'd have n plus 6. Here it's negative 2, and we would have n plus 6. So look, it worked both ways because this is factorable. It just has the two factors in a different order, n minus 2 in the front. But we know that multiplication is also commutative, so it doesn't matter if this is in the front or this is in the front. That was cool. Let's try it again. All right, we'll make our mod chart. We're going to multiply the first times the last, and we get negative 15p squared. And it has to add to give us the middle term. All right, so negative 1 times 15, negative 3 times 5. Is that it? And then, of course, we can switch all of these, right? We could have p times negative 15 and 3p times negative 5. So we're looking for the two numbers that add to negative 2. Well, here it is. 3p plus negative 5p is negative 2p. We found it. So we're going to replace the middle term with those two numbers or those two terms that we found. So I'm going to put 3p, minus 5p. All right, let's factor by grouping the first two and the second two. So the GCF of the first two, it looks like is 3p. And we'll have p plus 1. And the second pair, remember, you always take the sign that's in front. Always, always. And our GCF is 5. So negative 5. So negative 5 divided by negative 5 is a positive p. Negative 5 divided by negative 5 is a positive 1. And they match. So our final answer is 3p minus 5p times p plus 1. There we go. And you can always check your work by multiplying. There's not much the Desmos calculator can do for you on these problems yet. We'll talk about a little bit more about that when we get to our next lesson, but truly this is super brain power that you're going to need. And you all have it. I believe that. Last example, we'll make our mod chart. We're looking for two numbers that multiply to give us the first times the last. So that's negative 18n squared, and adds to give us the middle term, 3n. All right, so let's list our factors of negative 18. Negative 1 times 18, negative 2 times n, negative 3 times 6. Is that it? 7, 8, 9. Yeah, that's it. And remember, you can switch all of these. So, we can have a positive 1 and a negative 18, because these all will give you negative 18. It just depends how you write it. Negative 9 and 3 and negative 6. So look, we have lots of options. Do any of these add a to give us 3n? And they do. We found our pair of numbers. That will give us a positive 3n. Be really careful with your negatives. and positives, right? Because it can be tricky. We're looking for two numbers that multiply to give us a negative, but add to give us a positive. So we will replace the middle term. All right. And factor by grouping because we have four terms. So our GCF is n. This is where you might not need to write this out underneath every time. You still can. I'm just saying the more we form those processes in our brain, the more we can kind of do them in our head. But you can always write it out. So we'll have 2n here minus 3. Is that right? Okay. And our GCF here is 3. So we'll have 2n minus 3. Yay! And our final answer is n plus 3 times 2n minus 3. One thing I should have mentioned, and I'll add to this list, is always, whenever you're given a problem to factor, you should always see if there's a GCF of all the terms first. Remember we talked about in class that if you can factor something out in the very beginning, it's going to make your numbers smaller and more easy to work with. So I will do one of those in class. You can see that. The other thing, like let's look at this one. Here, I'm just going to add a slide really fast. You can add this in your notes. B squared plus 8b minus 7. Minus plus. This is what I'll just show you briefly the guess and check. So we know we want it to be like this, right? And we know because of FOIL that our first two terms are going to have to be that, right? Because FOIL says that the first numbers multiplied together give you this. B times B is B squared. And we know that the last terms have to give you this. So we know that the only thing that will give you a 7 is a 1 and a 7. So you can see, look how fast that was. Just got the same answer. B1 plus B7, the same. So this is the guess and check method. We're basically using our knowledge of FOIL and multiplication and what it means for something to be factored. So again, we know it has to look like this, and we know something about these terms. So guess and check is not terrible, but it really can only be used in certain cases. Like it's only easiest when you have a coefficient of 1. If you tried to guess and check on this one, you'd have a lot of guessing to do and a lot of checking to do. But I did want to show you, I mean, it can be beneficial in some cases, but you do have to have a really comfortable understanding of FOIL and what it means to be factored, right? Like these first two terms multiply together to give us this. So you know it has to be B and B. Like we know there's no other option. Because 7 is prime, we know there's no other option besides 1 and 7. Let's say this was like a 9. That's the whole checking part, right? It could be 1 and 9, or it could be 3 and 3, and you'd have to check each of those. Just wanted to put that out there. Okay, I am going to link some extra practice for these if you want them. Don't forget about our 15 minutes of fun sessions on your schedule for this week and our open office hours on Thursday. Please reach out if you need any help, and I look forward to seeing you on class. Bye, everybody.